This is another video in my series on kinetic molecular theory, particle theory as we call it, and the 7 basic tenets. Today I want to focus in on phase change, which is perhaps one of the most interesting and misunderstood processes of all of that. And in the water cycle, most people are familiar with that. You can see I've kind of got the whole, or at least 2 components of the water cycle right here. I have a pot of boiling water, which is one of my favorite things to continue to use. Obviously the bubbles are filled with water vapor because they're being superheated at the bottom. That's one of the few places you can ever see water vapor. And then as the water vapor's being released at the surface here as bubbles, it's rising, of course, because of the heated air around it. And then you can see it's formed recondensing back into a cloud of what we recognize as steam. People often think steam is water vapor. No, it's actually condensed water. It's liquid water. And over here I have a fan, and for our demonstration today, I want to show one of the most important things, which is what we call energy of state. How much energy is stored when water is a gas. And most physical science textbooks have this demonstration where the students take their hand in water and then they put it in front of a fan. Here I just have a small one, and very quickly, because the wind of the fan increases the rate of evaporation. I always use the back of the hand, but very quickly you can feel how cold it is. And what's happening here is the air from the fan is increasing the rate of evaporation, and that's causing my hand to cool very quickly. And most of us have experienced this. We've gotten out of a swimming pool on a hot day and realized how cold it is, and that's related. It's also the same reason when you get out of the shower or something, you're freezing cold. It's not the temperature of the air in the room, it's the fact that the water is stealing energy from your body to evaporate. The other challenge is the opposite of evaporation is condensation, which we can see rather vigorously going on here. And I developed a counter demonstration to show the energy of state of when water condenses, and it's a little bit dangerous, and I often warn students beforehand, they'll know when to go. But if we have a lot of water vapor here, which we've already demonstrated with the hygrometer, we can see that this will run right up to about 100%. I thought the same way we can see water condensing on the glass here, what if I can condense it on my hand? So I have students just place their hand over the top of the boiling water, spread their fingers so steam can rise, and it's actually quite delightfully warm. It's not hot at all when you first do it, but you'll notice something right away. As the steam rises or the water vapor, it's condensing on my cooler hand, and it'll matter for usually 10 to 20 seconds. You can sit here and it just feels warm, but very suddenly, ouch! You'll see that my hand is quite wet, and I've condensed the water, and this temperature change will happen very rapidly. What's occurring is when the water condenses on my hand, I'm having the exact opposite effect. It's releasing that energy of state as it turns from a gas back into a liquid, and that heats my hand up very, very rapidly. When you do this, you'll see how quickly it occurs. If the higher the boil, the more water vapor you're creating. But this demonstration, condensation here and evaporation here, explains the entire energy part of the water cycle. This is why a desert is so hot in the day. There's no evaporation to cool the air, and why it's so cold at night. There's no water to condense in the form of dew or frost and heat the air. And it's conversely the reason a tropical rainforest is so warm day and night. There, you have too much water in the air, and the water stores energy, so at night dew and condensation occur, and that heats the air, and during the day the abundant amount of evaporation cools the air, and so it makes a more uniform but higher temperature. So this demonstration of state is one of my favorites, and it really gives students the feel of what's going on in the most important part of the water cycle, what I often call the energy part of the water cycle. Moving energy from the surface aloft during the day and returning it back down at night.